In question 1, we're told to start with sine 3 theta, and by writing it as sine of 2 theta plus theta, to prove the identity that sine 3 theta is identical to 3 times the sine of theta, take away 4 times sine cubed theta. This is part A. Let's start with the sine 3 theta and write it, as we're told, as sine 2 theta plus theta. We should be familiar with the identity sine A plus B is identical to sine A times cos B plus cos A times sine B. If we use this here, we can write this as sine 2 theta times cos theta plus cos 2 theta times sine theta. To simplify this further, we can use the identities sine 2a, which is identical to 2 sine A cos A, and the double identity for cosine, cos 2a, which can either be cos squared A minus sine squared A, or 2 cos squared A minus 1, or 1 minus 2 sine squared A. If we look at the identity we're trying to prove, we can see that it only contains sine theta and powers of sine theta. It suggests that we use this form of the identity. So sine 2a, we only have the one choice. So the sine 2 theta here becomes 2 sine theta cos theta. We then have the cos theta. The cos 2 theta, as discussed, will replace by 1 minus 2 sine squared theta, and we then have the sine theta at the end. Expanding out, we have 2, a sine theta, and a cos theta times cos theta is cos squared theta. Over here we have 1 times sine theta, which is sine theta, and minus 2 sine squared theta times sine theta, which is minus 2 sine cubed theta. This cos squared theta, we can use sine squared A plus cos squared A, which we know is 1. This rearranges to give that cos squared A is the same as 1 minus sine squared A. Substitute this in here, and we get 2 sine theta times 1 minus sine squared theta plus the sine theta, take away 2 sine cubed theta. Expanding the bracket, we get 2 sine theta times 1, which is 2 sine theta, 2 sine theta times minus sine squared theta, which is minus 2 sine cubed theta. Then we have the sine theta and the minus 2 sine cubed theta. All we need to do is tidy, 2 sine theta add sine theta is 3 sine theta, and minus 2 sine cubes take away another 2 is minus 4 sine cubed theta, as required. So let's look at part B. We already know this identity. Sine 3 theta is identical to 3 sine theta, take away 4 sine cubed theta. And of course you could use this in part B, even if you couldn't prove it in part A. We're told that sine theta is equal to root 3 over 4, and we want the exact value for the sine of 3 theta. So the sine of 3 theta is going to be equal to, and note this is an equals and not an identity, because we're now working with a particular angle. It's going to be 3 times root 3 over 4, the value of sine theta, take away 4 times root 3 over 4 cubed. Remember, sine cubed theta is a notation which means the sine of theta all cubed. So this gives me 3 root 3 over 4, take away 4 times root 3 over 4 cubed. Root 3 times root 3 times root 3 over 4 times 4 times 4. Root 3 times root 3 is 3, so the top of this is 3 root 3. And 4 times 4 times 4 is 64. So this is 3 root 3 over 64. So we just need to tidy now. This is 3 root 3 over 4. Take away, the 4's will cancel here, giving 16 on the bottom and 1 on the top. So we have a 3 root 3 over 16. Multiplying the first term, top and bottom, by 4 gives us 12 root 3 over 16. Take away 3 root 3 over 16, and 12 take away 3 is 9, so we get 9 root 3 over 16.